Alright, hello, welcome back to A Software Engineer Plays, where we are back in TIS-100, and we are done with the sequence counter this week, or this video. We'll try the signal edge detector, and we're into new territory here. None of my friends have actually completed this level, so I don't have anything to judge myself against, so let's see what we got. Okay, read a value from in, compare the value to the previous value, write 1 if changed by 10 or more. If not true, write 0 instead. The first output is always 0. Okay, so interesting. So we need to bring in the top number into the accumulator, and then we need to store it somehow, but we can only do math with the value in the accumulator. So I think we need to send a copy to move it to the right here. And then I think we're going to want to just move it back. Alright, let's just read our story here. Cycles and cycles, I'm sick and tired. People who don't respect me, time to pack it up, huh? Alright, well, we've got some problems there. Okay, so let's see what this gets us. What does it get us? I don't think we want to do that quite yet. I think we want to move up into the accumulator again, so that'll get us send 0 across, bring 32, right, we want to move the 0 back, move accumulator right, sub left, right, sub right. So we should end up with a negative 32 here. But I've got my directions wrong, so I need to move the accumulator left instead of right. Did we... Ah, okay, we ended up with a negative 3 that time. 0 comes across, end up with 32. Okay. So at this point we need to subtract 10, I believe, and then let's see, if that is negative, if it's move 1 down, otherwise move 0 down, jump start. And I'm not sure this is going to handle the first case of sending 0, but let's just see what happens here. 0 comes back. So we do send 1, okay. Right. Move right down. Left. I know what directions are. Okay. So this should theoretically work. It's just it does not handle sending the 0. Let's see if we get a 0 now. Yeah. Yeah, not quite working. And the reason for that is that it doesn't handle negative numbers. So we need to do some additional math to make sure that the number is always positive. And we can do that. So jump is less than 0, negate. Otherwise, we're getting into what we would call spaghetti code here. Okay. So now we should still, we'll be off by 1. But we can always move 0 down. Okay. There's our 0. Now we send a 1. Uh-oh. Alright, what happened there? Let's see. So this one, it should have a copy of 30. 30 comes in. Oh, I see. See, I'm dealing it with these numbers in pairs, not every other one, I don't think. Right. Well, let's step through this again. So 0 comes in, and we're checking that against the 32. Yes, 32 is greater than 0, so we send out a 1. Now 30 comes in, and we're no longer comparing it against the 32. So we have some fundamental flaws in our logic, and that is not a good thing. And this would be the problem here, this second move up into the accumulator. So let's just see what happens if we take out that second. The answer is not what we want to have happen. Let's step through it and see what happens. Okay, so the 0 comes in, we move it right, then we sub what's the right, we send a 1, but it's not. Okay, so let's get rid of this stepping through. Okay, 0 comes in, we sub the 0 that was there already. I see a problem, and that problem is we do not want to move the accumulator right away. Okay, because that way we are not oh boy. Okay, so the problem here is as we move the accumulator right, we then bring it straight back. So we're dealing with the same number every time. So 30, it's always 0 this way. Which is not what we want. And I think, let's see, we've removed the second we don't want to move the accumulator to the right away. Because right now, if we skip over this step, then we would be subtracting the right, which would be 0 if we had it available to us. But we do not have it available to us. Okay. I think maybe we need to rethink how we're doing this. So let's start fresh. We know that we need the first number and then the next number. So maybe if we move up right, move left accumulator. Okay, so that'll get us our first number. And then move up accumulator. That's our second number. Just double check that. 0 goes across, 32 comes in. Then we subtract right. Left. And then this is, I think we're gonna have to just do this part once on the first pass through, because otherwise we're dealing with pairs of numbers again and not shuffling down, if that makes sense. So the 0 comes in, then the 32, then we subtract it. Oh, and then we'll want to move the accumulator across. Yeah, okay. If we can we do that? I mean, we need to keep a record of the 32. And if we do our subtraction, then well, let's see. Jump less than 0 to negate. Go. Okay. So I think what we're gonna have to do, first of all, we subtract 10, and then can I hit enter? jump less than 0 to send 1. Otherwise, why is my enter key not working? Let's work. Oh, I see. Because there's this thing all the way down here. Move 0 down. Jump, clean up, send 1, move 1 down, clean up. I'm gonna make this shorter so that I can fit more. CLN. So basically we want to undo all the math that we've done and then move our accumulator value over to the right. So in this case, well, let's see if we can figure it out by stepping through. 0 comes across, 32, subtract 10. Well, we definitely want to add 10. How are we going to handle if the number was negated, though? Excellent question. Well, this will work for some cases, I think. How do we get a 37 over there? Huh. Yeah. Oh, because I don't even move it. Alright, so in theory, we should then get a 32 and move that across and pull in a 30. Then we subtract it, it's negative. And shoot, I need to jump back in here to go. Huh. Okay, so 30 comes in, subtract 10. Send a 0. Add 10 back. 32 goes across. 32 is now waiting for us. We subtract it, get a negative number, get a 2, get a negative number. We send 1. Now it is a 2. Which is not what we want. And the reason for that is we don't have enough room in here. Now we do. That's still not the right number. All because of the negation happening here. So if we read in a value, save it. See, that's what we want to do. Instead of this stuff, we want to save. All right, before we even do that, save. Swap. Swap, move, accumulator, right. Okay, so now we should save a copy of 32 there, do all of our math, get our 32 back, move it over, get rid of this redundant command, try again. Okay, so 32 saved, we do our math, we send the 32 back, 32 is now ready for us, 30 comes in, subtract it, it's negated, subtract the 10, it's negative, so we move 1. Things now still are not working properly. Okay. Whoa! Okay, so clearly something is not quite right here. And I think it has to do with, well, obviously it has to do with my math. So I'm thinking, you got two numbers, you subtract them. If the absolute value is less than 10, in this case, 32 minus 30, or 30 minus 32 is negative 2. The absolute value of that is less than 10. So what's going wrong here? Okay, we got our negative 2. Excuse me, let me bring back that part. We end up with a negative 2. There's our negative 2. So we negate it. Now we subtract 10, and it is less than 0. So we're going to send 1, which means that but that's, oh, we're off by a number here. You see, because boy, okay. So when we subtract our well, I mean, I think we're backwards, and then we're off by 1. Because those are, in fact, yeah, okay. But now, as this comes in, negative 2, 2, good. 1, 0, it should come up 0. And it does. Let's just see if we're off by 1 for all of these. Yeah. Okay, so we just need to figure out how to move a 0 down. Maybe we reverse these. Let's see what happens. Because we've got a 0 in the accumulator to begin with. So we send that 0. Uh-huh. Hey, hey. It appears that we are working. So we just reversed a couple of commands and we were able to get rid of an entire command by doing that, which has saved us a command and cycles. So I can't say for sure that this is, well, it doesn't look like it's the fastest solution by any means. Let's see how we do up against the charts. Yeah, pretty far from the fastest solution. But pretty good for node count and decent for instruction counts as well. I imagine it would be possible to maybe parallelize this to a certain extent. And maybe do some crazy logic with jumping around, but this way at least makes sense mathematically how to do it, and how the math's all working. So I might come back to this and see if I can get it faster, but for now it's solving the problem, and I think it does it in a pretty concise way, actually. Now we don't actually, look at this. I don't know if this is going to save it that much. It'll save us another command, which is nice. Oh, ha. Okay, well, I take it all back. Why didn't that work? We should have just been able to move this down to the bottom. Get rid of this part. Oh, I see, because I need to jump to the... Okay, there we go. Did that actually save us any time? No, probably not. But it looks a little cleaner. Is it any faster? Marginally. So hey, just a little bit of rewriting of the code and we seem to be... Yeah, we shaved off 10 cycles on average, so not bad. Anyway, I'm pretty happy with that. Might be able to speed it up later, but for now I'll say thank you very much for watching. This has been a Software Engineer Plays. If you did enjoy the content, please consider liking, subscribing, commenting, ringing the notification bell, telling a friend, you know, all those things. It means a lot to me when you do that, so anyway, I hope you have a wonderful day, and we'll see you in the next video. Thanks. Bye.